Okay, so today we're going to go ahead and talk about how to find the acceleration due to gravity. So just to start, I drew myself on top of the Earth. I'm on the Earth. So we know the acceleration due to gravity on the surface of the Earth is about 9.8 meters per second squared. I'm going to go ahead and prove it. So fun. We're going to talk about that and finding the acceleration due to gravity a certain distance above the surface of the Earth. Cool. So what I want you to think about first is think about two equations that we could use to find the gravitational force between me and the center of the Earth. Go ahead and write those down. Okay, I'll do it too. So for two equations that I know the normal equation, F, I'm going to call it F little g, that we've been doing all year. So that is just the mass of me times the acceleration due to gravity at that point. Cool. The other equation is F big G, so Newton's law of gravitation, where that equation is big G, the universal gravitational constant, times the mass of the two objects. So in this case, we're looking at the mass of Walker times mass of the Earth, okie dokie, divided by the distance between the two, and it's again the center to center distance. The distance between me and the center of the Earth is just the radius of the Earth, so I'm going to say divided by radius of Earth squared. Cool. So again, we're solving for acceleration due to gravity, so let's go ahead and simplify this. Everything's multiplied on the top, so we can just cancel out mass of Walker, and I am just left with acceleration due to gravity is big G times the mass of the Earth divided by the radius of the Earth squared. Cool. So I'm just going to go ahead and plug in numbers to see what it is. So G is, again, the same thing everywhere, 6.67 10 to the negative 11. I'm going to go ahead and use a table. I know the mass of the Earth is 5.97 times 10 to the 24th. I'm also going to use a table to plug in the radius of Earth, which is 6.38 times 10 to the 6th. Cool. Now what I'm going to do is I'm just going to go ahead and put that on my calculator, be very careful making sure to put everything in parentheses, and I get, when I solve it out, 9.78 meters per second squared. Cool. So that is about 9.8 meters per second squared, which is the acceleration due to gravity on the surface of the Earth, and we just proved it. Gosh, that is so darn cool. Okay, let's go ahead and now do part B. We're trying to find G at a point 2RE away from our surface. So I'm going to go ahead and draw it out. So again, now we're looking at B. So we are 2RE all the way up here, and center of the Earth is RE. Okay, so this, and I'm going to go ahead and go back to our previous stuff. This little G that I just found is G on Earth's surface, because that is big G, mass of Earth divided by radius of Earth squared. What I first want you to think about is acceleration due to gravity as we move away from Earth's surface, is it going to be more or less? Well, Earth doesn't have as much of a pull on us, so it's going to be less. Acceleration due to gravity is going to be less there. So let's go ahead and see if our math proves it. Okay, so now I'm going to call this like G at this point. I'm going to call it G nu. It's going to be the same idea as this other thing. Acceleration, or big G, universal gravitational constant, times the mass of the Earth, divided by the distance from where you are to the center of the Earth. I want you to think about what that is. That is just 3RE, this whole entire distance right here. So 3RE squared. So now we can put that in. GME over what? 9RE squared. Okay, so I'm going to pull out this fraction. So it's 1/9 of G mass of the Earth over radius of Earth squared. Okay, so I want you to look to see what that is similar to. This whole thing right here is just the same thing as G on Earth's surface. So that, we can just rewrite this as it's 1/9 of what G is on Earth's surface. So we're just comparing it to what it originally is. So it's like 1/9 of 9.8, or if I'm lazy, I can put in 10. So I'll use 9.8. So 1/9 of 9.8 is about 1.09 meters per second squared. Cool. So isn't that kind of fun to do? Cool. So I'll go ahead and show one more example similar to example B. No need to watch, but if you want a little more practice, I encourage you to try another one. Okay, so now we're going to go ahead and look at this problem. So we have the dwarf planet Pluto has 1/500th the mass and 1/15th the radius of Earth. So we want the value of G on the surface of Pluto. Okay, so I'm going to say we want G on Pluto's surface. So we'll essentially use that same acceleration due to gravity equation. And again, we could derive it too just imagine if you know there's someone on there using our FG equation. And again, I could say like mass of U times G on Pluto is going to be G times mass of U times mass of Pluto over radius of Pluto squared. Again, that's assuming you're standing on the surface of Pluto. Mass of U cancels out. I guess you don't matter. Totally kidding. You do matter. We all matter. Great. G on Pluto. So again, that's big G, mass of Pluto over radius of Pluto squared. Okay, so now let's go ahead and see what I can plug in. So I'm comparing it to Earth. So this is going to be G, mass of Pluto is 1/500 the mass of Earth, over the radius of Pluto is 1/15 the radius of Earth squared. Okay, so now let's go ahead and simplify this a little bit. So we have 1/500 out front times GME over, okay, this bottom, let's simplify it. So let's distribute the squared. So we're going to have RE squared. I'm going to distribute the 1/15 squared. 1/15 squared is just 1/225. And again, I just pull that out because 1/225 times RE squared, same thing. Just makes it easier for later. Okay, so now let's go ahead and go back. What we said, remember on the last problem, that G on Earth's surface is just big G ME over RE squared, which is just the number 10, 9.8 to be more exact, but 10 to make our math easier. So again, this whole thing is just the G on Earth's surface, which is 10. So we can substitute that in. So we essentially now have 1/500. Oh my goodness, I should simplify that first. Okay, so let's simplify that first. So 1/500 divided by 1/225, that's just going to be basically 225 over 500. And again, now we're plugging in what the acceleration due to gravity is on Earth's surface times 10. So I simplify that. I'm going to just simplify the bottom. So it's basically 225 over 50. Cool, which is 80. And again, I just essentially did 10/500 to get my 50. Awesome. Thanks for watching.